Hi, and welcome to Geology. So today we're going to be talking about ternary diagrams, which are diagrams that we use to help us figure out any type of information using three different variables, and that's what this is saying here. Ternary diagrams are a plot of three different variables. So we can use this in any of our three series of rocks in our rock cycle, our igneous, sedimentary, or metamorphic. We're going to be talking about it today with metamorphic. But we're going to just look at how to read these diagrams because we'll see them kind of frequently throughout the class here. So the biggest thing is to be able to read them and then understand that the total percent of all three plots always have to equal up to 100%. Always, always, always. That's really important, that 100% there. And so here's our actual ternary diagram that we are going to kind of be looking at today. So as you can see, there are three sides to a ternary diagram, like a triangle. We have oxygen, we have silicon, and we have other elements. And as you can see, I've kind of color-coded this for us so that you could kind of visually see how to read this. And as you can see, our three different axes actually have percentages on them. I'm going to start here with oxygen. And so we're just suggesting that these are elements in the Earth's crust, which they are. We've talked about this. This is our silicate kind of minerals that we're looking at. So the way to read this is to start at the bottom. This would be 0%, and then we would move all the way up to 100%. You can see each line then represents 10%. 10%, 20, 30, 40, 50, 60, 70, 80, 90, 100. And so we can use these to be really helpful. The hardest thing to understand about them is just the reading part of it. So if we are reading a variable that is on this axis, we are going to be looking at the lines that run across this way here. And so I have a plot right here. If I were to try to explain how much oxygen is in this element in the Earth's crust, I would just say, okay, I've got 20, 40, and 60, and we know that's going up by 10, so this would be 50%. So there would be 50% oxygen in this value. And then we would just do the same for the other ones. So as you can see, I've kind of color coordinated it here. So purple would go up this way. If we were to read the other elements, it would start at 0 here and then move all the way down to 100%. And we would be reading these lines that I have colored in as blue. So once again, looking at this plot, we can see that it sits on that 20%. So there's 20% of other elements. And then finally, once again, we want that to equal up to 100%. So if we look at this chart here, we can see that our axis down here, it starts at 0, go all the way up to 100, and we would be reading the green lines that are horizontal this way. And so the percent of silica that would be in this representation of our variables would be 30%. So then if we were to add them all up again, we would have 50 plus 20, 70 plus 30 would be 100. So we've reached 100%. And so that's kind of how you read a ternary diagram. So today you're going to practice that a little bit, and then as you can see, there's a couple of questions that go along with this, and then you're going to try to set one up on your own, in that you're going to have to tell me where does that plot fall on this ternary diagram. So you're just going to use your drawing to plot it in, just one plot right there, so that you can kind of get used to it. We will see this quite a bit in the next couple of days, as well as you will see it on a test. So hopefully this was helpful. Once again, ternary diagrams, always wanting to equal up to 100%. Thanks.